doing a very important sum and a very interesting sum. Let's see the sum first. It says CD and GH are respectively the bisectors of angle ACB and angle EGF such that D and H lie on sides AB and FE of triangle ABC and triangle EFG respectively. Triangle ABC is similar to triangle FEG, and we have to prove three things there. To prove, we'll think later. First, let's see what is given. It says that CD and GH are respectively the bisectors of angle ACB and angle EGF. Now, let's see if CD is a bisector. When we know that, so what do we know about that angle BCD and angle ACD there? We know that they are going to be equal, and in other words, we can say that the measure of each would be half of that angle ACB. That means we know angle BCD is equal to angle ACD is equal to half of angle ACB. Same way, if GH is a bisector which is given to us, so what can we say about angle EGH and angle FGH? We know that they will also be equal, and each of those angles will be half of angle FGE. That is what we have. So we have angle EGH is equal to angle FGH is equal to half of angle FGE. So we have this from the given information. There's one more information given, that is triangle ABC is similar to triangle FEG, and we need to prove that CD upon GH is equal to AC upon FG. We know that when we want two ratios to be equal, we need to get the triangles to be similar. But which two triangles? That is what we need to understand. Now we know that this ratio, when we have, it is nothing but when we have products, two products to be equal, we get ratios. So same concept which I have taught, right? Same. So when we have those products to be written in the form of a ratio like we have here, first job is numerator should form one triangle and the denominator should form other triangle. That is what we know. So from the numerator, we should get one triangle. If you look there, CD and AC, do they belong to one triangle? Does it form one triangle? Yes. Which triangle is that? It is nothing but triangle DCA. So we got one triangle, right? The denominator, if you check, that is GH and FG. Does it form one triangle? Yes. Which triangle is that? The triangle is nothing but triangle HGF. Now we know that these are the two triangles which we need to prove similar. That means we need to prove triangle DCA is similar to triangle HGF. If we get this, we are getting the proof. Believe me, we get the proof. So we want these two triangles to be similar, and once we get it, we get the third part also of the two proof. So let's focus on this. Now for that, we are going to use the given information. One more given which we have, that is triangle ABC is similar to triangle FEG. Now you know that if these two triangles are similar, what can we say about angle C and angle G? We know that those two angles will be equal. Why? Because they are the corresponding angles of similar triangles. So we have this, right? Now, if you look at what we have got here, we have half ACB, we have half FG. That means we can get half and half here by multiplying half. So we write there multiplying both the sides by half. So we get half of angle ACB is equal to half of angle FGE, right? We got that now. Now once we get this here, this is, let's say, statement number 1. Right, and what do we have there? We already have that angle BCD is equal to angle ACD is equal to half of angle ACB, which is our statement number 2, and we know the reason why, because CD bisects angle ACB. Same way, we can write angle EGH is equal to angle FGH is equal to half of angle FGE. We know why, because the reason is nothing but because GH bisects angle ACB, and this is our statement number 3. Right, now this is going to all these 3 statements, right? So from here what do we get is, that is, we have that statement number 1, we have the statement number 2 and the statement number 3 all here, and this is going to help us to prove that triangle DCA is similar to triangle HGF. We need to get these two triangles similar, and believe me, I have given you the 3 statements and I know that you can do it. Now I want you to try it on your own. I'll be back.